All right, what's good, chat? Hello, everyone. Um, yeah, we're just gonna be doing these, doing more differential equations for this time 90 minutes, non-stop, just one 90-minute session. And then depending on how many people are here at the end, I'll maybe have a little talk at the end. But yeah, feel free to study along with me, and I'll see you in 90 minutes. What's up, guys? Hello. Okay, we've got quite a few people here, and I've had a change of plans because I'm actually free for longer than I thought. So yeah, I'm gonna take a long break, and then we will come back for about 30 minutes or so, just a little bit extra. Okay, hello. How many periods, where one period is 90 minutes, do you study in one day? Not that much, but in general. But hopefully for like the next month or so, I plan to be doing about 3 to 4 periods a day, apart from Sundays maybe. Yeah, with exceptions, of course. But yeah. I'd like to know how you take notes while studying a subject independently from textbooks. Independently. Oh yeah, from text. I don't know. I mean, my way of making notes was just making videos. To be honest with you, that was I found a really effective way to learn stuff. But I think doing the exercises in the textbooks. I mean, you don't have to go through every single one. Like no one's forcing you to or anything. But I definitely think going through some of them at least is helpful. And just try to make sure that you're understanding like what you're reading. Don't be afraid to take forever to read like one page of a book, like you know, and that's just how it is sometimes. And yeah, I think nowadays actually with AI, obviously AI can get things wrong a lot, so don't rely on it. But I think if you could, I mean, now you can ask. You don't even have to Google stuff. Well, Google is probably better in general, but if you have some really niche question about like a very specific part of a book which you can't find, you can always ask the AI like, what did the author mean by this? And quite a lot of the time it'll probably give you a pretty decent response. Sir, please tell me how to get into MIT. Well, I'm well, as you can tell from the title, I'm not at MIT, and I don't know. I don't know what tests you have to do or whatever, but I don't know. Work very hard. Get a little bit lucky probably as well. Yeah, I mean you're gonna have to have like excellent grades, but I believe in you, Mr. Nishan 9402. Oh yeah. Yeah, oh yeah, probably doing Olympiads and stuff would be very helpful. Yes, yeah. Okay, well I've got loads of viewers. This is technically my third semester, if you want to call them semesters. But the way they do it in Cambridge is the first 2 semesters are, you learn stuff, whatever. And then this third semester is like exams. So I'm not actually learning anything new this semester. I'm just here revising what I've been doing the previous 2 semesters. But yeah, you could say I'm technically in my third semester. But I'm currently, yeah, as I say, not learning anything new right now. I'm just looking at stuff from the first 2 semesters. Speaking of, I might as well go through what I was doing just now. Let me flip the camera. All right, so we were continuing with differential equations, moved on to the 20. Yes, yeah. The exams are like for the whole year. Yeah, which is probably a little bit annoying, but oh well. I guess it gives you extra time. Anyway, let's have a look. So, moved on to 2023. The first question was this third order differential equation, but of course, No worries, Mr. Max Musterman. It's my pleasure. How many hours do you recommend to study? I mean, I don't want to put a number on it, but a decent amount is, you know, probably helpful. Say I'd say 3 hours if you're like really a serious guy. I think how you study is also very important. I mean, 3 hours of really good studying is better than like 10 hours of just like sitting there doing nothing. Um, so yeah. Okay, actually, you know what? Let me just respond to the chat. When the chat gets dead, then I'll show what I was doing. um, how many courses have you taken at your university so far? I've taken so in first year, for a maths at Cambridge, there's no choice in what courses you do. So I've done 4 applied and 4 pure. The 4 applied ones were vectors and matrices, which is like linear algebra, but not pure. So like just like the applied side of it, like diagonalizing stuff, finding eigenvalues, eigenvectors. So that's vectors and matrices. Vector calculus, pretty self-explanatory. Just, I think the American version of that's like Calc 3, if I remember my black pen, red pen well enough. The third applied one is differential equations, which I'm doing right now. that counts as an applied course. And then fourth is dynamics and relativity, which I am not the biggest fan of, to be honest with you. I'm not very good at dynamics and relativity. But those are the 4 applied courses. And then the 4 pure courses are analysis, which is okay. I mean, it's a lot. I still have a lot to learn. You'll definitely in the future see me studying some random analysis theorems, trying to memorize the proofs. But we got analysis, groups, which is interesting, but annoying to do in an exam. But I like groups, but in the exams they can be a little bit tricky. Probability, which is actually somewhat interesting, but I'm pretty bad at it. But I think I can get good before the exam, hopefully. That's my hope. And then finally, numbers and sets, which is probably like, if you've done Olympiad stuff, that's probably the easiest. But if you haven't, then it's pretty difficult. And I haven't. But some of numbers and sets is actually all right. But again, you'll see me in the future tackling some numbers and sets, like modular arithmetic. We do some set theory stuff like surjections and stuff, whatever. But yeah, those are the 8 courses that we have this year, and yeah, we have 4 papers. Each paper is on 2 courses, and that's what I'm studying for right now. They start in June, so that's why I'm studying right now, because it's not that long. All right, let me read the rest of the chat. How many? Oh yeah, that's what I just answered. Like 8 hours after school is probably not advisable. I would not advise that. But you do you. You know what I mean? If you can handle 8 hours after school, then that's very impressive, and you'll probably be one of the greatest mathematicians ever in the future if you can genuinely do 8 hours after school of maths every single day without feeling absolute crap. But I definitely wouldn't recommend it. Let's have a look. What else? How many dimensions do your differential equations have? Normally just like 1, 2. Yeah, maximum 2, I think. Yeah, nothing. We don't go too crazy here. We have a little section on PDEs, but it's nothing crazy. Please go into relativity. I want to be able to ask an expert. You know what? I have a good idea. Yeah, I say you become the expert, right? And then I'll ask you, because I am. Yeah, no. No. Maybe I will. I mean, it's somewhat. I mean, relativity is probably my favorite part of dynamics and relativity course, to be fair. Dynamics is just kind of boring. Or not even boring, I just like find it kind of difficult. But yeah, relativity is all right, to be fair. Maybe I will become an expert one day. But I suggest that you become the expert. That's what I would suggest. There's a deeper meaning there. There's a deeper meaning. Why do I major in maths? Well, if you go back, if you sort my videos by oldest, you'll see that I've had this channel for quite a while. And that is indicative of the fact that I've always liked maths. And that's basically why I do it, because yeah, because I mean, it's always been my favorite subject. It's always been my best subject as well, thankfully. And so yeah, I thought, you know, if I'm going to go to university, I might as well do a subject that I enjoy. It also has the benefit of being very useful in life, but I want to just go into academia, so yeah, it was a pretty much a no-brainer. The real question was, where did I want to go? I mean, I chose Cambridge because it's apparently the best for maths. I mean, it is pretty good. I can't complain. And you know, I scraped in by the, you know, I got in well, I didn't really make the grades, but they let me in anyway. So here I am. But yeah, I just wanted to study math. That's why. Yeah, I guess that's why. Just joined. Greetings, my friend. Let's go to MASH together. I mean, okay. I assume you're at Cambridge if you're if you're saying that, Mr. Smile E5R. If you see me around town, you know, say hello. We can go to MASH together. I aspire to study maths at Cambridge one day. Well, you're in the right place. You know, we're all locking in. We are all locking in. I hope to see. I don't know how old you are actually, but if you're roughly my age, if you're only a couple of years younger than me, then I hope to see you one day at Cambridge, Mr. Tat Tvam Asi 108. Okay, it seems like the chat has sort of dried up. So in the meantime, before I sort of shut up, I might as well show you what I was doing. So let's flip the camera. All right, what do we have here? So yes, I started the 2023 paper, and yes, there was a third order ODE, but if you look carefully, it's basically just second order ODE. You just let u equal to y prime. So that's what I did. I solved this second order one, which was really annoying. They always do it. I mean, they can't just make it easy like this. I mean, obviously, you know, I guess why would they make it easy? But it's one of those ones where, firstly, the homogeneous solution had a repeated root, so you have to add in this linear term. And secondly, if you look carefully, you see that there's an e to the 2x here. So I had to, because I already have this thing, the repeated root, and the fact that, and you know, I need this thing. I don't know how to explain it, but basically I needed to multiply not just by x, but by x squared for my particular solution. And then I differentiated, you get this sort of long thing, and then you differentiate again, you get this really long thing. But of course, when you sub it into here, I didn't bother writing it all out. I just sort of looked like which things cancel out. A bunch of stuff cancels out. And in the end, you're left with this. And I got this. And ChatGPT didn't agree with me. I asked it what it got. It kept on getting different answers, and I'm not convinced. I mean, it's very, 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 very possible that I made an algebra mistake here. But I got this, and then I plugged it back in. This is obviously y prime, so you need to integrate. Did the integration, and I got some ugly looking solution, but you know, nonetheless a solution. Which again, yeah, ChatGPT didn't agree with me, but oh well, whatever. I don't have the solutions for 2023, so I guess I'll have to ask the supervisor. But anyway, that was that question. Then we went on to another short question, which was this. And for a second, I didn't really notice that this was just a normal separable first order ODE. which it just is. So you just separate it, solve it. This is just sec squared y hiding in disguise. I was surprised. I kind of forgot the trig identities, so I need to remember those. But yeah, solve it, and you get the they gave you boundary conditions, so you get the constant, and then oh yeah, you get this, but you have to add 2 pi. I mean, I wrote the branch in 2 pi to 3 pi. Maybe I have to just add 2 pi or whatever. But yeah, okay, that was that. That was pretty simple. And then part B was just another first order ODE. This time, with the like, you just multiply by the particular integral, get it in the right form, and it's pretty simple. So that was actually quite a free question. I was quite happy with that. And then I saw this juicy looking long question 7, which was about the Dirac delta function, Heaviside function, and this first part was really confusing, so I need to look back at this first part. I'm probably just going to ask ChatGPT what the answer is, because like I have genuinely no idea what they wanted me to say. They said show that delta of PT is equal to delta of T over absolute value of P, but I mean delta of T is just 0 everywhere apart from at 0, and like I just didn't know what they wanted me to do. That was like the very, very first part, so I assume it was something quite trivial that I just missed. But then the next part was to show that this identity is true. Oh, sorry, not that this the next part was to show that this identity is true. So I started with this because they gave me this, pretty much. They didn't give me this, but if you apply it to f prime, you get this, and then just integrate by parts. This thing obviously goes to 0 because delta of t is 0 everywhere, so the limit will have to be 0. And then this thing is exactly what we wanted, so you get the required result. That's pretty easy. And then this was just one of those ones where there's lots of parts, and all the parts are not too bad. And then they wanted me to show that h prime, so the Heaviside function, its derivative is actually Dirac delta, which I didn't know, but I thought about it for about 5 seconds, and I thought, yeah, that must be true. And then you have to think about how you're going to prove it. Turns out proving it is not actually too bad. You just compute the integral, do integration by parts, and you get that this thing, well, we've said, I mean, I haven't said it, but in the question it said that a is less than 0, it's less than b, and the Heaviside function is obviously 0, so at a it's 0, and at b it's just 1, so you get this f of b, and of course, the integral from a to b of something times the Heaviside function, well, anything below 0 is just going to die. So this is the same thing as the integral from 0 to b of, well, this is just 1, so that. And of course, fundamental theorem of calculus, bish bash bosh, you get the required result, and you have the Dirac, that the Heaviside function, its derivative is Dirac delta, which is kind of interesting, I thought, but anyway. Then, yes. Then they gave me coupled differential equations. Coupled differential equations. Is this stream still going, by the way? Yeah, it is. Okay. All right. Oh, sorry. I haven't seen the chat. Oh dear, I missed the chat. Okay, I'll respond to you guys in a second. Oh no, I'm losing viewers and the chat. I'm not responding to the chat. Anyway, I'll respond to you guys in a second. You had to, I don't know, solve these couple differential equations. It was with the Heaviside function, so you have to be sort of failed, but I eventually sort of got it. All right, let me respond to the chat. I didn't realize that my OBS is not responding for some reason. But okay, let me respond to the chat first things first. What side of? Oh, my break is over. I'm gonna just respond to the chat and then we'll Um, we'll work for another like half an hour or so. Nothing crazy. Okay, what were people saying? If you want to, okay. How old are you? I am 19, and no, I did not take a gap year. Tenses are too hard to wrap my head around. Yeah, okay, well, same here, mate. Same here. um, what side of maths do you like the most? Pure, probably. Like, I mean, my favorite part is probably homological algebra, but unfortunately, we don't do that in first year. So, but well, again, homological algebra. I have a paper out with Christian Furco, Ishon, and Castro that you can find in Mangelman, but using the tools of homological algebra. Yeah, more details on my channel. What else? Do you like playing active on Fortnite in 2018? Maybe 2019 as well. But since then, I have not really played Fortnite. I did very much like the complex thing in maths. I'm like 16. I don't know. Have a think about what. I mean, it sounds like you're very interested in a lot of things. Obviously, I don't know you. I don't know where your passion really lies. What could you see yourself doing for a few years? And just do that, I guess, or just be more pragmatic and just be like, what am I best at? What, have a think about that. That sounds like you're in a good spot. Did COVID influence your childhood a lot? That's an interesting question. It probably, I mean, childhood happened. It happened when I was like 13 or 12 or something. Yeah, I mean, it would definitely indirectly. I'm sure the social consequences affected me very much. But yeah, I mean, it affected my childhood a bit, but not too much. Not too much. I think it happened at a good, well, at a roughly good time because it didn't affect my early development. So, I don't know. I don't know. It did, but not too much. What was your reaction when you got into Cambridge? Ah, okay. Um, okay, so I got put in the pool, which is basically the college saying, we're not rejecting you, we're just sending you out to all the other colleges to see if anyone wants to take you. Because I missed them by quite a bit, so I thought, oh, well, let's just put everyone in the pool. And so I was just, obviously I was checking my emails like every 10 minutes, like, have anyone accepted me, what's going on? So I just checked my email, I just said, well, I'm in. I don't know, I was very happy. Yeah, I was very happy. Yeah, I don't know. I was with my dad, and then, yeah, we called my mom. Yeah, it was a good day. That was a good day. um, do you feel like modern day academia is not the same as it was? I mean, it's probably more specialized because we just know more stuff. So like we're probably very unlikely stuff. But I think in general it's much more specialized. But I can't say too much because I'm not currently an academic. But yeah, that's what I would say. Use Claude. It's relatively better, so I probably will. What was the
exact question one with the delta? The question with the delta was show that for any non-zero p, delta is equal to, which I mean, I don't know what they want me to do. I don't know what they want me to do. Sound is bad. Apologies. I don't know why that happens. Sometimes it just happens. But anyway, it's not going to matter because I am going to be going back to work. We relax for the rest of the day. Yeah.
All right. That was actually a somewhat productive 30 minutes. Yeah, that's definitely the end. Okay. Thank you for sticking around for so long. I'll see you next time or some other time. I'm gonna assume that everyone who commented is still here, even though that might not be true. Bro, you're going bold, you should chill and rest. Okay, I'm gonna chill and rest now. Don't worry. But yeah, I'm not sure any amount of chilling and resting is gonna save me, but yeah, okay. Yeah, cheers for that one, mate. Come on, you got this. Thank you, my friend. Thank you. Yo, I got the leaks IFYW. I don't know what that means, but congratulations. Yeah, I don't know. Bro is geeked. Yeah, maybe that's slightly true. What you studying? Differential equations. Let me show you. In fact, oopsie daisy. Let me show you what I was studying. What was I doing? Yes, I actually managed to get in another long question, which is more than I thought I would. Question 5. What was question 5? It was about first order ODEs, and they wanted me to give the general form for like how to do it. So you just multiply by the integrating factor, and you get this like ugly looking thing, but in practice this is like pretty decent, the fact that we can actually do this. So they wanted me to derive that, and then they said if you have two functions that both satisfy the thing, then what's like the general form? Well, the difference will satisfy the homogeneous equation, so you just add it basically. And then they wanted me to solve this, which was actually kind of interesting. You do the algebra, whatever, do exactly what they tell you to do up there. You get the you multiply by the integrating factor, and you get this thing. You get this as your expression, where this, like, I don't know if that's the error function precisely, but some sort of error function type function plus c, and there's only one value of c for which this has a limit. This converges as x goes to infinity, and that value of c is minus root pi over 2, because as x goes to infinity, this thing will be 0. And in fact, we can compute this limit, because this thing right here is, if you plug in c as this, then you get that this is just the integral from x to infinity of e to the minus t squared dt. And then if you consider the limit as x goes to infinity, we can put this on the bottom. In fact, I dropped a minus sign somewhere, but whatever. You can put this on the bottom to make it a 0 over 0 case, and then use L'Hopital, because we know what this is going to be by fundamental theorem of calculus. And then, yeah, it works out to be, I think, minus a half, although maybe I dropped a sign. But yeah, okay. And then I started. So that was a surprising amount of, like, I didn't expect to get through the whole question in half an hour. So that was good. And I had a little bit of time. I began an equilibrium point question, but I realized I didn't actually really know what was going on. But yeah, that's what I did in the last half an hour. Yeah, I've got a decent amount of viewers. Let's see if how many problems have you solved in this session? I've solved, well, this here, and then in the 90 minutes before that, I solved this long question, so that's 2. And I did 2 short questions as well. So I did 4 during still learning, well, revising. I'm pretty happy with 4 questions in total in 2 hours. And then obviously I did some this morning as well. So I've actually been pretty burned with physics. I mean, you do you, mate. You do you. You know what I mean? But yeah, unless the chat has anything to say, I am actually going to see you guys tomorrow. And thank you everyone who's tuned in.